Grade 7s, welcome to your daily lesson of mathematics brought to you by WorksheetCloud. Hope you guys are well today and looking forward to today's lesson. Just another reminder of the email address on your screen, grade7@worksheetcloud.com. Please feel free to use it. Get in touch with me, send me any feedback, suggestions of work that you'd like me to cover. Perhaps you have a query about something I've taught before and you just need a little bit more clarification, and I'd be happy to get back to you regarding those pieces of work. Today we're looking at algebra and we're looking at like terms, and as always we have our warm-up and our mental arithmetic questions covering previous taught principles, and then we have our brain bender and finisher to end off with. Here is your warm-up activity for today. You need to tell me the value of each symbol in this fraction themed warm-up. Don't forget the question mark at the end. As always, write everything down. Write it down logically, methodically. Make sure you understand what you're writing down. Check your work. Make sure everything works out. And don't be too concerned if you have to start again. We are looking for you to develop a little bit of resilience when you're doing these types of puzzles, as when you encounter a tough question in an assessment, you're going to need that resilience to work through it. So let's see how you guys get on. Off you go. So I'm going to start on the third line. Chocolate bar divided by 4 is equal to a half. So that's going to be 2 divided by 4 is equal to a half. Remember, 2 divided by 4 can be written as 2 over 4, and 2 over 4 is a half. Okay, so that means I have 2 is equal to 1 plus 1. Okay, now I need to go to the top line, and I know that my answer is going to be 2/3. Okay, so I've got 7 over some bananas minus 1 over some bananas is equal to 2/3. So I cannot have a denominator of 3 because 7 over 3 minus 1 over 3 is equal to 6 over 3, which is equal to 2. All right, so now I need to think about a fraction that's going to be equivalent to 2/3, but it's going to have a numerator of 6, and what's the denominator going to be? So I know that 2 over 3 is the same as 6 over 9. Okay, so 7 minus 1 is equal to 6, so that means my bananas must be 9. Okay, and remember, when we subtract fractions, we keep the same denominator. Okay, so 7 minus 1 is 6. The denominator stays the same as 9, and 6 over 9 is equivalent to 2/3. We just divide 6 by 3, and we divide 9 by 3. So in my final line, I'll have 7 over 9 plus 2 over 9 plus 2. Okay, 7 over 9 plus 2 over 9 is going to give me 9 over 9, which is equal to 1 whole. And then 1 plus 2 is equal to 3. Okay, I think the trickiest part there would have probably been the top line and figuring out the denominator of 9. If you guys work through that and you remembered the principles that we covered when we did fractions, then well done. Let's have a look at what your mental arithmetic questions are today. 9 mental arithmetic questions are on the screen. Okay, as always, work through them slowly, methodically, write everything down, and remember to employ the correct checking strategies when you've done your answer. Okay, off you go. Let's see what we got. So we've got a relatively short addition question to start off on, but just notice that you've got 3 units in the top line, and then you've got 15 in the second line. So it's crucially important that you have the correct numbers in the correct columns. Okay, a very common mistake would be to do something like this, okay, and then add the 1 and the 8, the 2 and the 5, and put the decimal wherever it is, and leave certain numbers out. That's going to be pretty disastrous. So just avoid making that careless error and make sure you have, tens, units, decimals, tenths, hundredths, etc. Really helpful if you want to put a 0 in, just so that the numbers kind of match up in terms of how many you're dealing with. And then we just add normally, and you need to carry where necessary, and there's your answer, 19,01. Your checking strategy is then to subtract a number from 19,01. So you can either subtract 3,21 and your answer should be 15,8, or you can subtract 15,8 and your answer should be 3,21. Let's subtract 15,8. And let's see what we get. We get 3,21. So my original calculation must be correct. Okay, your second question for the day is subtraction. Okay, and we are subtracting 13,721 and 5,819. Okay, and again, make sure the numbers are in the correct columns. And then we just need to borrow where necessary and subtract as per usual. And we should get an answer of 7,902. Remember, your checking strategy here, guys, is to go the opposite way to subtraction, which is addition. So 2 plus 9 is 11. Yes, that works out. 0 and 1 is 1. Yes, that works out. 9 and 8 is 17. That works out. 7 and 5 is 12. And that's pretty much what we're left with. And now I know if all of those things work out, I can move on confident knowing that I got that calculation correct. Okay, long multiplication, 56 times 15. Let's have a look at the double and halving method. So if I halve 56, I get 28. If I double 15, I get 30. If I halve 28, I get 14. If I double 30, I get 60. If I halve 14, I get 7. If I double 60, I get 120. And now I can't go any further because I don't want to halve 7 to get 3.5, because then I'm working with the decimal, which I'm trying to avoid. So now 7 times 120. You know that 7 times 12 is 84. Okay, but I need to include that 0. So your answer is 840. But let's check that with another method. Okay. So perhaps we go 56 times 10 first, and we get 560, and then we do the 56 times 5, which is obviously half of 56 times 10, which is half of 560, which is going to be 280, and if you add those together, you get 840. So we must be correct if both methods show up the same answer. And I like to do long division using multiplication. So first I'm going to go 24 multiplied by 100, and that equals 2,400. Okay, I'm also going to say multiplied by 200, and that's going to be 4,800. So I haven't really done anything too complicated. If I have a look at 5,640 and 4,800, I can see that I'm only 840 away. All right, so how many times does 24 go into 840? Well, we can say 24 multiplied by 10 equals 240. So therefore, if I multiply it by 20, it's going to give me 480. Okay. If I multiply it by 30, that's going to give me 720. Okay. And remember, we were looking for an additional 840. So I'm 120 away. I know that 24 multiplied by 5 is 120. Okay. And now it's just a case of adding up numbers. All right. So I know that 24 times 200 is 4,800. All right. And I know that if I multiply 24 by 35, I'm going to get that additional 840 I was looking for. Okay, so that means 235 multiplied by 24 is going to give me my 5,640. So your answer is going to be 235, and I'll just stick that in here. Okay. But now we need to check, and we're going to check it by doing 235 multiplied by 24. And I'm going to guess or estimate that I'm going to use a doubling and halving method. So if I double 235, I get 470. And if I halve 24, I get 12. I can do it again. Double 470, I get 940. And that's multiplied by 6. But I'm actually going to go one further and double 940. And that's going to be 1,880 multiplied by 3. Then I'm going to say 1,000 times 3 is 3,000. 800 times 3 is 2,400. And 80 times 3 is 240. Okay? Now if you add all those numbers up, you'll see that you're going to get your original answer of 5,640. Now, it might seem a long-winded way to go about it, but I mean, let's be honest, I didn't really do any complicated calculations there. I multiplied by 100, I then doubled it to multiply by 200, I multiplied by 10, doubled it to multiply by 20, multiplied by 30, I just added another, however many it was multiplied by 10, and I just worked it out using subtraction. So for me, those methods are really, really easy. And I do prefer them to the more complicated algorithm that long division used to be taught with. So I encourage you guys to get your head around using multiplication to work out division sums, but always remember to check your answer at the end. That's really, really important. Okay, so the next question is the addition of fractions. So we have 3/4 and a fifth. And the first thing you should have noticed is that the denominators are very different. So I need the lowest common denominator of 4 and 5, which is 20. 4 goes into 25 times. 5 times 3 is 15. 5 goes into 24 times. 4 times 1 is 4. And that gives us 19 over 20. Okay? We are multiplying by 10 in question number 6, and you know that when you multiply by 10, your number becomes one place bigger, so that's going to be 1,340,9. Okay. Question 7 is the division of a fraction by a whole number. Okay, remember we can write that whole number as a fraction just so that we're dealing with two fractions. Remember, when we divide fractions, the division sign changes to multiply, and the second fraction, or the fraction after the division sum, gets inverted to its reciprocal, and it's a case of multiplying the numerators, multiplying the denominators. The answer is 3/8. Question 8, 2 1/4 multiplied by 4/5. First thing I'm going to do is I'm going to convert 2 1/4 to an improper fraction, which is 9/4. Remember, 2 times 4 is 8. Plus the numerator 1 is 9 over the original denominator 4. Multiply that by 4/5. Now you can say 9 times 4 is 36 and 4 times 5 is 20, but then you're going to have to go simplify 36 over 20. So it includes or involves additional steps. You can simplify in the question diagonally. Now, all you have to do is multiply the numerators. 9 times 1 is 9, and the denominators, 1 times 5 is 5, and that is your answer. 9/5 is equivalent to 36/20, but I'm going to say it again, by simplifying or cancelling out diagonally in the question, it avoids the need to now simplify 36/20, okay? Remember that if you needed to write this answer as a mixed fraction, 9 divided by 5, 5 goes into 9 once, and it leaves you with 4/5. Okay? And then your last question is to find 25% of 400. And well done if you recognize that 25% is a quarter, and that all you needed to do was divide 400 by 4. Okay, that's great. If you didn't recognize that 25% is a quarter, then what you would have needed to do was to say 25% over 100 times 400 over 1. All right. Remember that 25 over 100 is the same as a quarter. So you could have just written a quarter times 400 over 1. And then we know that 4 goes into 400 100 times. And then your numerator, you've got 1 times 100, which is 100. And your denominator, 1 times 1, which is 1. And that leaves you with 100. Okay? Yes, you could have absolutely have done, well, what's 10% of 400? 10% of 400 is going to be 40. So 20% equals 80. If I know 10% is 40, then 5% is going to be 20. And there you've got your 20% and your 5%. And it gives you the same answer of 100. Okay? So guys, I hope you work through those. Go back, rewind. Make sure you understand any areas that might be a little bit gray for you. Send me an email, grade7@worksheetcloud.com, if you want me to explain any concept further or in more detail. But remember that on WorksheetCloud.com there are lessons on every single one of these concepts, along with an online activity and memo, and I'd encourage you guys to make sure you fully understand these concepts before you get to grade 8. Right, let's go have a look at the main theme for today. So today we're going to look at like terms. So in an algebraic expression, it is made up of terms, okay? And there's also operators such as plus, minus, multiply, divide, as well as brackets, okay? So remember, an expression is something without an equal sign, and then as soon as you put an equal sign in, it becomes an equation. So a term is made up of numbers and letter symbols, but not operators. Okay, so for example, 3a plus 4b minus 5 minus a plus 5, that is an expression. There's no equal sign there. Okay, 3a is a term, 4b is a term, a is a term, and 5 is a term. So there are 4 terms in that expression. All right. 3a and a are called like terms because they both contain the number and the letter symbol a. Very important that we recognize that both a's are small. So if it had said 3a and the other a had been a capital letter, those are not like terms. They have to be exactly the same. It doesn't matter about the numbers in front of the letter, as long as the letters are both small or perhaps both big capital letters. But yeah, those are like terms. Okay. Let's chat about collecting like terms. So remember, in algebra, letters stand for numbers. So we can use the same rules as we use for arithmetic. Now, what do we mean by that? In arithmetic, if you had a question 5 plus 5 plus 5 plus 5, you can also write that as 4 multiplied by 5, okay? Because there are 4 groups of 5. So in algebra, if you have a plus a plus a plus a, you can write it as 4a. Remember, we do not need to write the multiplication sign, okay? So 4 multiplied by a is written as 4a. Another reminder that the number comes before the letter. The a's are all like terms, okay? They're all small, so you can add them together to get 4a. So we collect together like terms to simplify the expression. Okay, so let's remember that in algebra, letters stand for numbers. Okay, and we've already said that we can use the same rules as arithmetic. So looking at the example on the screen, 7 multiplied by 4 plus 3 multiplied by 4, it's exactly the same as 10 multiplied by 4. So 7 multiplied by 4 is 28, and 3 multiplied by 4 is 12. If you add those two together, you get 40. So it's 7 groups of 4 plus 3 groups of 4, which is exactly the same as 10 groups of 4. Okay? In algebra, it's the same. 7 multiplied by b plus 3 multiplied by b. 7 groups of b plus 3 groups of b is going to give you 10 groups of b. Okay? And remember, we don't write the multiplication sign. So it's 7b plus 3b is equal to 10b. Notice that both b's are small b's. They are like terms. 7 plus 3 is 10. Okay, so let's have a look at this. 2 plus in brackets 6 multiplied by 2 minus in brackets 3 times 2. All right? So that is going to be the same as 4 multiplied by 2. If I look at the brackets first, 6 multiplied by 2, so 6 groups of 2 minus 3 groups of 2, that's going to give you 3 groups of 2, and then you need to add that additional group of 2. So that's how we get the 4 groups of 2. So in algebra, very similar, if not the same. We've got x plus 6x minus 3x. All the x's are exactly the same. So x plus 6x, 7x, minus 3x is 4x. Okay? So the similarities between arithmetic and algebra are very, very apparent. X, 6x, 3x, and 4x are all like terms purely because the x's are all small. They all look exactly the same. Okay, when we add or subtract like terms in an expression, we say we are simplifying an expression. Okay, so we simplify the expression, we make it shorter, more concise, and we do that by collecting like terms. So an expression can have different like terms. So for example, we have 3a plus 2b plus 4a plus 6b. Now you can see straight away that there are two different letters there. A is in red, b is in green. So we can only simplify this expression by adding together the like terms. So the like terms are 3a plus 4a, and then the other like terms are 2b plus 6b, as I've rearranged and identified on the screen. So 3a plus 4a, 3 plus 4 is 7a, 3 groups of a plus 4 groups of a is 7 groups of a, and then 2b plus 6b is 8b, 2 groups of b plus 6 groups of b gives you 8 groups of b. Okay, so 7a plus 8b is going to be the most simplified version of that expression that you can make. You cannot go any further than 7a plus 8b. Okay, so here are some expressions that you can simplify by collecting like terms. So I'm going to put them on the screen. I'm going to give you a couple of seconds to answer them. Okay, so for question number 1, you should have identified, first of all, that all the a's are exactly the same. They're all small. Okay, there are 5 of them. So a plus a plus a plus a plus a is equal to 5a. All right, remember there's no multiplication sign between the 5 and the a. All right, 5a means 5 multiplied by a. In the second question, you've got 5 groups of b minus 4 groups of b. Okay, that's going to give you just b. Remember that we don't write the number 1 in algebra. Here you've got different like terms. All right, so you need to have a look at which ones are the same, and I've color-coded them to make it a little bit easier for you. All right, so if you rearrange them, and it's not necessary to rearrange them, okay, you can just work through the example without rearranging. But if you did rearrange it, just make sure that you keep the sign that goes with the particular term. So you can see that there's a minus sign before 2c. That minus sign must stay with 2c if you rearrange. Okay, there's a minus sign in front of just d. You must make sure that if you rearrange that the minus sign stays in front of d. Okay, and now it's just a case of saying 4c minus 2c is 2c, 3d minus d is 2d, and then 3 plus 6 is 9. Okay, in question number 4, you can rearrange to say 4n minus 3n, so 4 groups of n minus 3 groups of n, plus n squared, and that's going to be n plus n squared. All right, so I'm sure you guys are getting the hang of it by now. In question number 5, there are no like terms. Okay, so 4r plus 6x, so for 6s minus t cannot be simplified because there are no other terms that you can add to 4r, 6s, or t. Okay, algebraic perimeters. Okay, so don't be concerned that algebraic perimeter sounds like quite intense, but all it is if I gave you a shape and asked you what is the perimeter of that shape, well, you know that the perimeter is, we add up the lengths of the shape to get the distance around the outside, and you know in a rectangle the opposite sides are equal, so you've got 2a plus 3b, but then you've got another 2a plus 3b, so therefore your perimeter of that shape is going to be 4a plus 6b. Okay, there are two 3b's and there are two 2a's. Okay, another shape. Okay, so that trapezium, there they've given you the lengths of all the sides, and you can see the like terms are going to be 5x and x and 5x again. All right, so that's going to give you 11x, and then 4y stays by itself because there is no other y to add or subtract to or from 4y. Okay, so that would be algebraic perimeters, a really useful way to ask whether you understand how to work out a perimeter, and then on top of that, do you understand how to add and subtract like terms? Okay. Okay, guys, so that's the end of collecting like terms in that lesson on algebra. Just go back through the lesson and make sure you understand it. There's also an online activity with memo that you can work through just so that you consolidate that information. It's really important you understand this moving into senior school. And please let me know using the email address on your screen, grade7@worksheetcloud.com. If you have any queries or questions, or if you're unsure of something, or maybe I haven't explained something particularly well, or you just want me to explain it further and again, then email me and ask me, and I'll be more than happy to do so. Game of 24 is your finisher. And by now, I'm pretty sure that you guys know that you need to come up with the answer of 24 using the numbers on each card. So on the first card, you've got 2, 5, 2, and 3. Can you make up a sum using plus, minus, multiply, or divide, and those four numbers, and then come up with the answer of 24? Okay. Grade 7s, thanks for joining me today. I hope you guys learned something. Please go through the lesson again. Online activity and memo is there to help you, and let me know if you have any questions. Keep safe. All the best.